Okay, we're back, everyone. Sincere apologies there, and appreciate everyone's patience. We were just getting a few. Okay, we're back, everyone. Sincere apologies there, and appreciate everyone's patience. Sincere apologies there. Sorry about the feedback there too. I was still on our live YouTube at the same time. Okay, welcome everyone. A very good evening, good morning, good afternoon, wherever you are in the world. We appreciate your time and effort for being here with this webinar series. Before I hand over to Dr. Stephen McKee, I'd like just to highlight a few Zoom housekeeping rules, and that is we appreciate everyone being muted and videos off the whole time during the webinar. As said, due to we're doing some live feed from our factory, and we appreciate not having too much interference, so appreciate your working within those boundaries. Also, using the chat feature, we may not be able to respond immediately, but we'll have a record of all your chats. So if there's anything you wish to ask, please put it in the chat. Thank you very much. So that's it from me. I will now hand over to Dr. Stephen McKee, the President and Founder of Labtech International, who'll just also give you a quick welcome. Thank you very much. I think he's there. You there, Dr. Steve? He should be coming on very soon. Just waiting. Thank you.
Echo, tell Brad that we're trying to connect the sound.
Test.
Okay, you're just testing.
Yes, we're testing.
We could hear you, Steve.
Can you hear me now?
Yes. Can you hear me?
Yes, I can.
Okay, over to you. We'll spotlight you now. So I will remove the spotlight, remove the pin, and I'm trying to see where you are.
I'm on the VLearn camera.
Okay, if someone could spotlight the VLearn camera, please.
We'll start from here or from that side. So
I think we will go there. Yeah. All right, so follow me. Okay, I'm not seeing anybody listed.
okay, so that's the monitor.
Okay, there we go. Right. I don't know what you're pointing the camera at. Welcome, everybody. Sorry for the technical issues this morning. It's our early morning here in Indonesia, so we had an issue getting the YouTube connected for the live stream this morning. We're also testing out a new audio system too as well that delivers a much clearer sound. So I'd like to welcome everybody here to the Labtech factory. This is a live tour. You're actually seeing from the factory all the different things that we will be making today. And first, just to introduce the team here, this is Mr. Nyoman Sutajaya, and we have also Mr. Eko Hernanto. So Eko is a director with our Labtech factory here and PT Labtech Penta in Indonesia. Nyoman is the factory manager. And so we've been working together now 35 years, a long time. And right from the beginning, where we made some very good products back then, but now you're going to see some amazing stuff here. Every year we're doing things that, quite frankly, amaze us all of what we're able to do. To give you an idea of where we are, I'm just going to take a step outside the camera. You can follow me. And we're going to take a look outside, because we're near the factory entrance here. And those of you, particularly from overseas, that have not visited the factory, we're kind of in an unusual location that we are on a hill. So we're actually not a typical factory location here. So behind me, you can see we actually have a beautiful, beautiful view over the South China Sea, the Singapore Straits. And Singapore is in the distance, actually. So we can see downtown Singapore. We can see downtown Singapore, and it's a very beautiful view that we have up here. A nice benefit that we have is we're about 40 meters above the sea, is that the wind comes up and blows through the factory here. So we're in a very tropical, very balmy place with surrounded by the sea, and there's also shipyards here. So Batam is a free trade zone. This is why we're located here, that we can bring in material from anywhere in the world, not have to pay duties on it. We can export to any of our clients around the world, and also not pay any duties or taxes. And so it's a very low cost, free environment for us to operate in, whereas many countries, particularly in Asia, have duty issues, importation issues, restrictions on material. They can't actually access all the technology available. Where we're located, we can import any technology from anywhere in the world, incorporate it into the new training systems that we do. So this is a very important part of Labtech's success. We also ship through the port in Singapore, which is the world's largest container terminal. And that provides a great advantage to us. So if you have the pleasure to visit, then you'll see the location. It's a wonderful location. Actually, it's a nice place to visit. There's a lot of things to do here. And we wish that you could schedule a trip in. So today we have joining with us our representatives from around the world, from many countries. We have senior education officials. We have industry partners. We have also we also have our partners from the schools and teachers and professors. And so everybody has a little bit different point of view. We're going to do our presentation today based upon, a general point of view of the items that we're doing. So what you see behind me here is, if you've been watching the video a little bit on the YouTube, we are highlighting the advanced training systems that we've been doing in electric vehicle. Electric vehicle training is in huge demand all over the world as EVs become more prevalent. There's still a small segment to the market, so we still have a huge traditional line of combustion engine for diesel and petrol and autotronics and things like this. But over the last few years, we really have been building out the product range, the training range in the EVs. And this year we've done some very, very special things here. And we have some brand new models. And so you basically are looking at what you see in front of you could be like what the training systems that you have in school. That everything you see here is being sold, is already sold and going to be exported to various countries around the world, from India to Panama to Belize to different countries in Asia, the Middle East, and so on. And so they're done to meet the needs of each client. We are very big on Toyota, working with Toyota, particularly in hybrid vehicles and hydrogen fuel cell vehicles. We do a lot of advanced work with them, and we're very proud of that association. In the EV range, we have been working with Nissan and Nissan Leaf, which has been very popular. What we have here is the BYD models that are coming out, because they now are gaining popularity around the world. So we always try to work with the models that are the most popular. So I'm going to ask Nyoman to join me here.
Yes.
And we're going to take you through a couple of the training systems. Now, what we have here is, what we're looking at here is what we call engine training system for an electric vehicle. And we do these for the Nissan Leaf before. We've done many of these. And it's also paired with our digital twin. And so what you see here is actually from this vehicle, or this type of vehicle. So if you look over there, this is a BYD Dolphin. So we're working on two models. The Dolphin is the basic entry level for BYD. It's very economical, which makes it less costly for schools. The technology, though, the platform of BYD is very similar across many, many different platforms. We also have the Atto 3, which is a larger SUV that you'll be seeing, the blue one that is over to my left also as well. So this is a training vehicle. And what we have here, I want you to come in. So this has been beautifully sectioned here as well. You know, all this part has been opened up, and and the workmanship here, I have to say, when you come and see it at the factory, is absolutely gorgeous. It's as good as the original bodywork. And the guys do a fantastic job. You know, we basically have the skills of a custom shop for automotive on there and what we do. And then down here, you see the control center, the heart of this. So this has the fault insertion system with a colored display on it. And these are all the test points. So in doing your fault systems, you'll be, the student will be working here with the test points. They can also have the test points at the original location too as well. But doing it here, it's safer, it's easier. Right. And because the test points are embedded in each of in actually the electronic circuit, they get a better understanding of what this electronic circuit means. They're able to explore the values, the voltages, the resistances throughout the whole area. And for a mechanic, automotive technician to understand the electronic circuit is the heart of the thing. This enables him to do systematic troubleshooting. So we always do this type of thing on many of our trainers, but it takes it to a very higher level on these electric vehicle training systems that we do here. Right. So, yeah.
Yeah, there's also we put different colors so they distinguish from the sensors and actuator. So it is very easy for students to understand and recognize which is the sensor for the battery, the sensor for the electric motor, and all the components explained very clear in this electrical diagram. So the test point here is very safe for students, and it also has the fault simulation here in this side, which can be combined for a lot of combination of fault simulation that can be inserted from that point. Okay, so this is the car body that section already. So this vehicle actually functioning as a normal vehicle, even though the body already cut it. And then here you can see the machines of the electric vehicle here. So this is the power control unit, and the electric motor is downside there. And then so this is basically same as a normal vehicle and can be running in a safe area. We don't recommend to drive this car in the road. Okay, so this is the half body, and then the other one here is the machine test bed. We call it test bed because we take out all the machine of the BYD Dolphins electric vehicle, and then we put on the frame, and then lay out here. Please come here. So this is actually the all machines of the electric vehicle. So this is the radiator here, radiator, and then the power control unit, and the electric motor here, and it has the air conditioning system as well here. So what's the benefit of this type of engine test bed? So actually, basically, both of this test bed and this cut body
Echo, can you direct
has a combination of purpose. So this
just
car,
make
because
sure that
it's
his
section,
camera is in the right position.
it is easy for the student to recognize everything inside of the car as what it is. We just take out the half of the body. But by having this of the engine test bed, the machine test bed, the student will be very easy to access every single part of the electric vehicle. So from this side, we can see this is the simple one, is the charging port. And then the charging port is connected to the inverter of the charging inverter here in this area. And then from the inverter, it will control the electric motor, and also it's connected to the electric high voltage battery in the side. So this is actually the EV battery. So this battery will be difficult to be accessed if it is still installed in the vehicles. So because it's assembled at the bottom side of the car. But by having it on the stand, on the frame like this, the student able to access, even to touch the battery. It is very safe because it's all covered. There is no high voltage here. So the high voltage all covered by the orange color. So it is very safe for the student. And then it has also the battery, the low battery here. And the other advantage of this machine test bed, because the machine actually put on the frame, in order to simulate the regenerative braking, we provide the regenerative braking simulator here, which is produce and assist the system to simulate the regenerative braking. On the other side, actually, I will show you from the front side of the machine test bed here. So this is actually the dashboard. All the display here, this board display actually we took out from the dashboard of the vehicle. If you look at this, it is exactly the same for the Dolphin. So you see this one. So that dashboard actually exactly the same as what we put here in the machine test bed. But the difference is the student able to access directly here. And they will recognize this is the, let's say that this is the gear shift of the control of the vehicle. And then this is the display, and then the display. And then we provide here also with the electric wiring diagram and test points, as well as the fault simulation system. So this is actually the one package of the electronic system, electrical and electronic system of the EP. So the test point here are all provided here. So the low voltage and high voltage. The good thing for the system actually, for the high voltage actually, if you can see closely on this. So the high voltage actually already scaled down by 1 to 10. So let's say the battery voltage should be 300 volt, but we measure here on the 30 volt. And what's the measuring here actually, the complement of the real battery voltage. What if there is changing on the electric motor voltage and current, it will also change in this test point, but safe for student because there is no real high voltage to be available here. So this
I'd like to emphasize that a little bit for the group. So this is actually a new innovation that we're doing across our high voltage vehicles. One of the problems that we have with safety for training is the high voltages, as Nyoman has said. It could be anywhere from 300 to 700 volts. And that could be very dangerous for students, particularly it has high amperage too as well with the DC power. And so to make this safe, we reduce it down 90%, so it's just 10%. So as Nyoman said, if it's 700 volts, it becomes 70. If it's 300, it becomes 30. And how we do this, I'd like you to invite you to look inside the technology here. You have to look at this. Okay, all right. So this is the electronics package that makes all this work. And you're seeing in here data acquisition systems, signal acquisition. We're putting this over a Wi-Fi feed as well, which we'll get to in a moment. But the board that's sitting on top, this one here, actually is the voltage simulator. And so this takes the voltages from the engine and the ECU and then drops them down to 10%. Yeah. And this can be communicated wirelessly as well. This is a huge innovation to this platform or this training platform that we use in all of our high voltage platforms now. So this is how Labtech designs things. that we look at it from a platform point of view. And you can see all the boards. All these boards are designed and made in Labtech. And also, one thing that we're very proud of is that our labeling and things of the cables, everything has a cable number on it so that we could identify all the cables. And so when we're working with our customers here, you can see here, down here, all the different cables, because you can have things, these are 4 or 5 cables, all that are red. That could be very confusing to a technician servicing our equipment. But with the cable number on each and every one, we can easily communicate about, what to do. So you have to check cable 1, 2, 3, do something to it. So our remote servicing is very good because of this. Can you turn that on?
Okay.
So we just want to share with you how there's a lot of interesting architecture inside our things. Now, coming back to this, that Nyoman is turned on the displays here. So Nyoman, why don't you start this up and run this?
Right. So in order to run this machine testbed, it's actually the same as what we do in the real vehicle. So it has the gear shift. It has the bottom side, also the accelerator pedal and the brake pedal, which is we have to press the accelerator in order to increase the speed and press the brake pedal to decelerate. So the first I will move it is now in the parking position. We have to press the brake pedal and move to the neutral. Yeah. Move to the neutral. Like this, it is neutral, and then move to drive. It is on the drive. And then you can see, maybe show the screen there. You see that there's also showing the drive test. If I release the brake, now the speed is increased there. I will accelerate. Okay, you can see speed is increased there.
140 kilometers an hour. Has no load on it.
Yeah. And as well as in this vehicle. So it is connected wirelessly. So what happened in the machine testbed will be showing on the computer screen.
Right.
And can be shared up to 20 student screen.
So this is what we call our digital twin. The digital twin is a digital simulation of the training system in full detail, And we can even rotate it around. This is exact copy of the actual thing. And we can explore various parts of this. We can look at it, we can flip it around and sorry.
This is the power control unit.
Yes, this is the PCU. This is the heart of everything that happens, for that. So, and you could do different things in this. So this enables the student to visualize this much better. And you could do a lot of experiments on here, which we're going to get into the various operations of this. We're going to explore this one in detail, but all of our digital twins work in the same way because we have a standard platform about this. So when we have a digital twin, they all communicate in the same way over the Wi-Fi system locally. So this is connected through computers, and this one here, right?
Yeah.
Is connected wirelessly to the training system. I'd like to point out the antenna. This is the built-in Wi-Fi antenna on the training system. There is also a cable connection. You can go through USB, but you cannot share then with other computers. The benefit of going Wi-Fi, we can have multiple computers. So this computer is connected. This computer is connected also.
Yeah, and
the one in front as well.
Right.
So we have 3 computers connected at the moment.
Yeah. Right.
But we could have up to 20. You could have a classroom of 20 students learning at the same time on this unit. No longer are you confined to just 2 or 3 or 4 students working on this. You can have a whole class of 20 or 25 students working on this. Maybe 4 working on the actual unit. Others are working on their workstations here and being connected and see all this. So now Nyoman is operating the trainer from the computer. And you can see how beautifully This works on a touch screen. You know, that everything is interactive. Sorry, you do this. I'm clumsy. I will talk, you operate.
Yeah,
Using the camera.
Yeah. Sorry?
We are losing the camera.
The camera is not on the
It's back.
feed. It's back.
Back now.
Okay. All right. Thank you. Right. So we can hear the engine operate in the background. You may not hear right now because we have noise canceling on our microphones.
you can see the wheel is rotated here.
So that shows that it's rotating. If we put on the brake, it would be able to do the regenerative braking as well. All right. So let's go into what we can do with this. We can operate from any computer. This can be assigned by the teacher. So even a student, the number 20, can actually operate the training system. But only one person at a time can operate because you could not have two drivers in a vehicle. You know, more or less, not a good idea. So we don't allow that. You can work on either local or remote.
Yeah.
If you're on local,
Yes.
you are able to control it through simulation, but not through the training system. If you're working on remote, you're actually connected to the training system.
Right.
You see we're IoT connected. So that means this computer is connected and it's authorized as the controller for this. All the data is displayed here. Again, can you do something? You're neutral. There you go. All right. So as the vehicle operates, we're able to see the battery, the vehicle speed, the motor generator, the output, the torque, the battery voltage, battery current, battery pack temperature. This is all signals coming from the engine management system for the electric vehicle. We've hacked into it and have brought the data out that we can use and manipulate on here. Next thing that we could do is we can look at the operation. You know, beautiful 3D graphic of this. And these graphics are also used in our Labtech Academy systems for learning about the motors, the batteries, the control systems, the brake system, everything about EV is also using these types of graphics here. But here it's animated. It's showing the power flows of what is happening. And this will change a little bit. Here we have speed, torque, and power that's displayed up here.
Yeah.
So if this then goes on, you know, then we can explore these types of things.
This feature also, let's say the teacher explaining to the student on the smart board, it also can be shared to the student screen. So let's say that student screen, for example, now you can see that. So the teacher can change from this screen or to the operational screen and the animation screens or the electrical diagram, even to the chart. Everything will be changing and shared to all the students. All 20 students will be able to access the same thing at the same time as what a teacher explained. And also teacher able to monitor what the student activity.
Right. And the lag time is very, very short. You know, you can see how instantaneous this is. You go back to this.
Yeah.
And how quick this changes. And what we're using is advanced gaming technology. It's the same technology that your kids might use on playing online games when you got thousands of people around the world playing simultaneously on the same platform. This is the same technology for this.
Right.
So one thing that Labtech's becoming famous with or for is that there are many companies that teach IR 4.0 and IoT technology. We do that, but we go a step further and use IR 4.0 and IoT technology for teaching and learning. We use that technology, delve deep into it, and use it to structure a new type of learning experience for students that brings more learning to more students across more areas and lowers the cost of learning per student. Because if you have 20 students learning at the same time, that's going to be a lot more cost effective than just two, you know, and all these systems, no matter who they're from, they're a little expensive. So you add a little bit more, have your digital twin, you can be 10 times more effective, you know, on your training here. Now,
I want to
what-
share a bit for the other feature of the digital twin. So this is the real time connections. So the real time connection by means is the computer, all the student computer connected to the machines. There is other feature for the digital twin actually, but we have to back to the main menu. So in this main menu, the first is the functional simulation, which is very useful for students to do the simulation offline by themselves, without connected to the machines, without observation from or the supervision from the teacher. They can learn and study by himself standalone. So if we run the functional simulation, all the features in the functional simulation is actually exactly the same as the features that are available in the real time connection. So it has the power button, which is we have to press the brake first, and then the power, and go to the neutral and drive, and then we increase the speed. So all the simulation will be running here exactly the same as what happened in
the
live one. So it also has the fault simulation here, which can be activated and simulated either by the testing mode or trial mode. The trial mode means the student can do their own experiment without the supervision of the teachers. So they will press the trial mode and then activate any fault. But they may not understand what's the fault is active by means if they press the fault number 1, they don't know. So before that, the teacher will need to explain to the student what's the fault list. Actually, it is available in the test mode. So the teacher know all the fault list. We'll need to put the password here.
It's okay.
1, 2,
Before
3,
somebody
4,
was
5. I
trying
think
to
the
share
default.
their screen external.
So that one. And then this is the fault list actually. So there are in this particular simulation, there are 20 fault simulators, which can be combined, active only one fault or two fault, or all together can be active at the same times. So let's say
And this provides over 1 million different fault combinations.
Yes,
It's
right.
very extensive.
so by having this all the fault simulation, let's say the easiest one is the accelerator pedal sensor malfunction. So by means if the accelerator pedal problem, so we cannot either we cannot increase the speed of the vehicle, or maybe the vehicle just run very fast if there is problem. The fault number 18. So this can be simulated by, let's say, what? Sorry. Please click the start. Yes, start station. Start fault number.
So the student has to log in
Student
And-
has log in.
and
And then put
so
the,
that each
the
student is ID'd, the results are stored for each of the students, so the teacher can see the results of each of the.
right. So this is the student data login. The student have to enter the ID number, for example, like that, and the student name. Let's say like that, A, and login. After login, they will be able to activate the fault number 18, for example. And then enter the fault. The fault 18 is active now. We also will be able to see the electrical diagram here. So actually, this electrical diagram exactly the same as what available in the engine and the machines control panel. So here, sorry, because we don't know the what fault is activated. So we can choose the fault hint. The fault hint in this case, because in the test mode, the teacher will need to provide the password to show to the student what is actually problem. So this is, we can see this problem is on the accelerator pedal position sensor.
So that's if the student needs help. What I just want to highlight is Yeoman's in the testing mode right now.
Right, right.
So the trial mode is the student can do all this exploration themselves,
Yes.
go through each fault one by one, get the guidance from the system, have the hints from the system, learn about the structure, about the answers, how things work. And once he's confident about that, you can enter into test mode.
Right.
You know, you would not start here. This is actually for testing. So there's two modes, one for learning, one for testing. So the learning is a formative assessment, you know,
Right,
type
exactly.
structure here.
Yeah. So, but at the early stage, maybe the teacher can explain for the student before they're doing they own experiment also
Sure.
possible. Yeah. So then in order to answer choose the correct answer, there is a lot of option of the answer here. The correct one is accelerator sensor. This one. If we choose the incorrect one, for example, this one, then it
Wrong.
is not
Instant
correct.
feedback.
Not correct. We have to try again. So,
And if we choose another one that's wrong, again,
yeah.
instant feedback. And so, which did you say was
The accelerator.
Try that.
One it is the correct one.
Here we go.
Then if we submit the correct answer, then the fault will be automatically released on the machines.
Right.
So
And then a record is here. That's very useful to see how well the student is doing on the test. In this case, there's only one question that was started. One correct answer, two incorrect answers, 3 chances. So this data gives you an idea of how well the student is understanding this system. If you have one question, you had 10 or 12 different incorrect answers, you know he's just guessing, you know. But if he got it within 2 or 3 or 1, he has a pretty good idea what's going on here. Yeah.
Exactly right. So that's about the fault simulation. So in the simulation, so in the
Very, very powerful for the student learning and for the teacher assessment. You know, I mean, this type of stuff is, it helps the teacher to get the student to a much deeper level understanding.
Yeah, also on the field, the simulation, actually, there are many other features here, actually. Before, actually, the student, before they are continuing to the experiment, there is introduction of the component identification of the electric vehicle. So this is the complete vehicle of the EV. So we can see here there's 360 rotation. Like this, we can see this the electrical battery, and then right, this is the powertrain, power control unit, and then the EV electric motor. Now this is the general information, but the more detail will be explained after this. The electric vehicle battery consists of quite many of components. So let's say this can be the exploded view of the battery. It is like that. A lot of components here. So consists of 10 types of main components.
Yeah, look at those circuit boards.
Yeah.
You know,
So
the detail on this, you may not be coming through on the image, but this is highly detailed
right.
and actually authentic, the actual stuff, you know, that this has
Right.
been modeled from.
So there's the contactor, the insulation, the bus, even the bus bar, the cooling. So this is interesting for the BYD battery.
Yeah.
Yeah, right. So it uses the air conditioning refrigeration system to cool down the heat on the battery. So
There's a lot of different types of heat management in electric vehicles.
right.
There's forced air, there's just convection, there is, and then BYD uses the actual aircon system
Right.
to cool the battery
Yes.
then.
Many vehicles using either the water for cooling or
Water.
the air. Yeah, but this one using the most effective for using.
Yeah, it is
the
very
refrigeration.
effective, very clever.
The battery pack is like this.
The blade battery,
Blade battery cell.
right.
It's
That's why they
included.
call it a blade.
Yeah.
It's a monolithic thing that it's modular. It's very clever
It's
also.
modular.
Wow.
And the battery management system.
Ah. These are the circuit boards. Now you can see a little bit more detail.
And the collector, battery lowercase. And that's the example of
Okay, let's go back. So you have this type of thing from the vehicle, the battery, the motor, the powertrain, the domain controller, the power management
Right.
system, cooling system, regenerative braking. So all these have different modules. We have just a short time
Right.
tonight or this morning. So you know, we want to spend a little bit of time on this, but actually we could spend 2 hours going over this and still not cover everything. I just want one thing here is the background theory. There's also traditional information about the entire system here on this, which is 20 pages for that. So this complements our Labtech Academy. Labtech Academy, we have over 20 EV training topics, and which covers each of these things even in more detail. But there is an overview of this built into the digital twin also, where it combined some of our Labtech Academy learning assets with the actual offline and online simulation able to be done over Wi-Fi. And soon, it actually is working right now, but we haven't publicly released it. Because it is Wi-Fi, it can go over the internet too. So you could even have students logging in or teachers logging in from anywhere in the world into that class. So you could be conducting a class and you could be having people from different areas. This would be very useful for professional training too, who are people who are working, who have a job, they cannot go to the training center to be physically there. So this could be open up new ways of learning, you know, without borders. And this is what we are doing with our new digital twin and systems like that. Right. So, Arno, are you there? Are you able to speak? Arno, are you there? You could get ready for the Labtech introduction, and also you'll be introducing the Labtech marketing team during that time. When you're ready, give us a signal. We will continue on.
Right.
And to do. So we're going to look at the rest of the things. Maybe before we get the others, let's end up over here. Okay, right. We'll end up over there. Right. So you're seeing things that are at the factory right now that are going out, but actually there's a lot in this area. This is a very interesting new product, electric vehicle battery pack trainer, which goes more in depth into lithium-ion batteries, which are the heart of many electric vehicles today. Maybe later on we'll be doing a sodium ion when it becomes available in the market, you know. Right. So we'll always keep up with the technology on various things. But this also has a digital twin on it as well.
Yeah, so this is the more a deep explanation of how electric vehicle battery. We can see here this is the training system for the EV battery cells. It has we can come here. This is the battery cell. It's like this inside. Yeah, this battery cell. This consists of many cells here. In this particular case, 24 cells. Each cell has 3.2 volt battery cells, and it is totally. It depends how many cells that we combine. In this case, about 76 volt and 50 amps. This is enough for driving a small type of vehicle, like say like the in go-kart like that. So this is the DC converter, and this is the charger controller. It has also the computer interface, and also the charging switch. And this is particular one is the battery pack load simulator. So this is the special load simulator to simulate the discharging condition of the battery. So it has also the 12-volt battery as in the EV system. So the mostly of the auxiliary battery or 12-volt battery is used for providing power to accessories of the vehicle like the headlight, and this one has the software, digital twin software, which is connected in this case to the USB connection, and we can change either local or remote.
Right. It works in the same way as the other one.
Yeah,
So
right.
let's not go into the detail of
Yes,
this.
right.
But we just show some of the graphics, you know. So it has the same function of connection, the same fault interactions.
It has
So
the
you
same
have the
platform.
trainer also that you can rotate around. It even has the graphics on here
Right.
from this.
So it's very detailed, exactly as what the trainer is.
Right. And you have your electrical diagrams and the charts and the plotting. So
Yeah, right.
once you see the digital twin, the student is able to intuitively do the next one, you know, because
Right.
the structure is very similar, you know, because it's a good structure. We look at improving the structures, and we'll do that for all things. Okay.
Right.
So we have several different type of charging system. Why? Because there are several different types of chargers.
Yes, right.
In fact, there are many types of charge. So we start with like a home system, and this is often bundled with our cars or vehicles or engines. It's a slow charge.
Slow charge, but
This is the slowest. This is like what you'd have in your garage, you know, and it just made a little bit nicer. So
yeah,
you
right.
can use this to charge our training vehicles, leave it on overnight, whatever. Your next level is an higher power AC charging system.
Right.
And so this has a higher amp, has a nice display on here, has the fault insertion system, and
Also
has
the
an app
controls,
to control it.
application also to control it. Yeah.
So it's a smart charger.
Yeah, it's a smart charger. We can start.
Everything
from,
is smart
yeah.
nowadays. If only we could be smart.
So the difference is in this particular, because this is a training system. So the charger is a normal charger, the quite fast charging system, but we provide with the load simulator. So why we need the load simulator? It is actually in order to simulate how the charging system work actually. So without connecting to the load, the charger will be not function.
Right. It just
We-
sits there.
Sit there. We
Right.
cannot run the charger without connecting to the load. And this is not a normal load, not a special load for EV, because there is a signals. You can see there are several signals on the port of the EV charging port that has to be simulated to trigger the charger to
Think
charge.
it's charging.
Yeah.
Yeah. And there
Plus-
is, it's actually a load.
Yes,
Yeah.
right. So this can be changed the load, low, medium, high.
So whenever we do a trainer, in order to get things to operate, we often have to have something to trigger it,
Yes,
you know,
right.
and in this case, a load. And we always have those things with our trainer. So it's not just you turn it on, you can't do anything with it. You can do see the full features of it.
Right.
Okay. And the next one we have is, this is example, your faster one, which is the DC charging system. This is, most of the fast chargers use this structure of technology. So we have one type that we do for clients on this one too. Again, it has faults and electronic diagrams. This we've been doing for quite a while. It's quite useful. It's a basic EV drive trainer. This is similar you would have to a small vehicle, golf cart, utility vehicle. It actually generates quite a bit of power and torque, you know, for this. And it has a nice display. It can function. We can turn it on, and we could do basic demonstration of how a drive system works for an actual EV. On vehicles, it's very similar to this. It's just upscaled,
Upscale,
more
yeah.
fine control.
And
right.
more fine control. Yeah, right.
Right. Okay. Like I said, this is a working tour. This is in process. And it might make you appreciate our technicians. It certainly makes me appreciate that.
There's a lot of wire.
Here we have two engines that we're doing. One is, aren't they both diesel?
This is a common rail diesel engine.
These are all common rail with
Common rail,
turbocharged.
yeah, with turbocharged, you're right.
Turbocharged, catalyst. Right. Transmission. But look at all that wiring. It is complicated. So we have to, we take this out of a vehicle.
Yeah.
We strip it out because all the parts have to match to work. And so the ECU is here and all the systems. And again, we have to hack into the ECU and all the signals for this. All the wiring has to be duplicated and sent out to the control panel. So
Yeah,
this is
control panel.
what will be here, the instrument panel, the electrical diagram, the faults and everything. The work that goes into this and the knowledge it takes to do this to this level, I have to say, share with you that this is really very complicated.
Yeah, so the engine is cleaned not only at the outside but also the inside because we overhaul.
Rebuilt.
Yeah, right. Change
Right.
the piston ring, the seal of the valve seals, everything is changing.
Yeah. So we have two types of engines that we can use for clients. We can actually do brand new engines, but the most popular ones are this level, which is what we call a reconditioned engine. It keeps the cost lower because brand new engines, one, they're difficult to buy because the motor car companies don't like to sell them.
Yeah.
So try to get it from their, you know, every engine they take off of the production line is one less vehicle they can produce, is how they think of it. So they don't want to sell the engine. Or a used engine in recent model, 5 years, maybe
Yeah,
10
about
years
5
at the
years,
most.
yeah.
And that's up to the customer, you know, what level. And then we rebuild it, guaranteed. And actually, probably for training, is better than a new engine in many ways and less costly. So there's another one over there. What you're seeing here is part of our air conditioning line. This is a miniature of a complex aircon
Ducting system.
ducting system, right?
Yeah.
And so we have combined all different types of joints that you might be designing and building, from splits to different types of registers of different shapes. We can have test points for the velocity. We can control the airflow and action.
Yeah, actually, this is not only the shape of the design, let's say the T or the U, but we also provide in the manual the calculation. So how to make the noise very low, or how to increase the flow, what's the correct pressure. That's why we have several dampers here and a lot of measurements. So every single duct, a small part of duct actually has its own calculation. Explained for detail in the manual,
Yeah.
and has to be matched with the source of the air, the blower.
Let's go over here.
Yeah, on that side.
Ducting is more complicated than it seems. It is really an engineering exercise. It is airflow. Airflow is a type of fluid, you know, and how it behaves and how it acts. It's very easy to get it wrong. So if you ever go into a building and spots are too cold or too hot, the engineer might not have understood this, and he should have gone through a Labtech trainer.
Yeah,
Understand that.
yeah, because how to send the air until, let's say, for 100 rooms or only 10 rooms, there's a different setting, and what's the requirement of the fan. So this is the main fan actually in the site. Yeah, that's
This is also one of our engineering drawings for the manufacturer. So a lot of our systems have visual build guides, and that are validated by the design teams.
Yeah, right.
And, you know, it's very visual the way that we have our instructions for this. And a lot of these graphics go back into the manuals
Exactly
too, as well. So they're dual purpose. Okay, we have over here some of our fuel injection trainers. These are a little unusual. They're monopoints. So this would be like a system that you replace a carburetor.
Yeah,
with-
right. So there's a previous version of the electronic injection system. Yeah,
It's
but
where it first started, actually.
Right.
For the first fuel injection systems 30 years ago or more, 40 years ago, 45 years ago, were single point. So it'd just be one squirt into that'd be atomized and go down into the manifold, and
then
that would be it. Now we have direct injection where the injection's going right into the cylinders and things like that, which we have training.
But it is actually because it is electronic control. It has all the sensors, very similar to the new type. The only difference is how the injection and
Anode
the
is ready to install.
ignition
Okay.
system provided. Okay, this is the similar system for both
Right.
of them.
Good. So now we're back to some of our training system again. These are what we call three-wheeler and two-wheeler or utility things. Golf carts might even be in this area. And it has, illuminations here of the different control areas, windows and things. It is operable here. You can see that this one is on right now. So it's displaying here. And we can work it as well. Yeah, there we go.
Yeah, it is working.
Yeah.
Because we
Right.
put on the stand that
Right.
will be not moving.
Right. It doesn't move.
Doesn't move. Only
So we
tire.
have again the electrical circuit diagram, the fault system and the displays. This one does not have a digital twin. We only put that on the really more sophisticated items.
Right. Yeah.
Something like this does not need that. The standard fault panel, for the motorcycles or the two-wheelers, three-wheelers is fine. Again, this is the fault system. And 10 faults gives you a lot of combinations, like 500,000 or so. All right. We're going to do one last item here in the EV area. Then we're going to switch to Arnaud to do a brief introduction, which should have been earlier. But we're going to end with something at this segment here before we go on to the air cons, the renewable energy for a very quick tour. This is the BYD Atto 3. And this is absolutely gorgeous. The paint job on this is a metallic blue. If you see it up close in person, you'd say, well, you'd like that on your car, this paint job. It's really, really nice. It's showroom quality. So we have beautifully sectioned this. The items also for the trunk area is also, why can't I get this open? I'll get help on that one. So similar to the other one, the control area is up here, and you'll have to get up here. So it's very similar to the other one, the Dolphin, where you have your board for the fault for the electrical wiring, and the fault systems with the color display. And you could also see that this vehicle is on, there for this. How this is different, it does have a digital twin.
Yeah, it has a digital twin.
And it also has something very interesting. If you come over here. So what you are seeing here, this is the digital twin for the Atto 3. And again, we can rotate it around. It looks really nice digitally too as well. So what do you have here? So this is actually how it's going to be set up. This is going to Center of Excellence in Latin America. And it's going to be a beautiful centerpiece for the lab for this.
So it has the 6 student computer and the teacher consoles. And then all the student computer and also the console box. This is we call console box, which is very, very useful for the teacher and student. The console box actually the replicate of all the signal enters point that are provided in the vehicle. So what is there, what the signal is there will be available as well on the teacher and also the student. When we drive the car, accelerate the speed, also the signal also changing on the student console, and it is connected wirelessly.
That's the magic of it.
Yeah.
This is actually maybe a world's first. I don't know if any other system does this. I know some people that have consoles, but they're connected by cables,
Right. Yeah.
and there are only a few signals,
Only
5 or
signals.
6, something like this.
Yeah.
This has dozens of signals here, and it's all connected wirelessly to the vehicle. So you could have more than 6 of these.
Right.
You could have 20 paired with the simulator. You're now actually to do real signals. You have a built-in voltmeter probe.
Right.
You can do your testing here. You can work with this.
Mhm.
It's a complete training system connected wirelessly to the training vehicle. This is absolutely game changer.
Right.
You know,
The interesting thing is actually the high voltage that provided in this console box of the student and teacher. Normally, the other system using the cable, so they connect the high voltage in the vehicle to the console, which is dangerous for the student. In this case, actually, we replicate all condition of the high voltage in the vehicle by converting the N-bus signal and OBD2 signal into the real analog signals.
Siri's trying to call
So
me. Can you
what's the
call her
changing
after?
of the level of the
going on?
signal of the
I cannot.
generator and motor will be also change here at the console of the student and teacher. So that's very, very useful and very safe for the student. The student will never pass the real high voltage because
Right.
it is the replicate and simulation.
Right. This is one of the reasons we developed that lower voltage thing, which is wirelessly connected to make it safe, but also to replicate remotely
Right.
the learning experience for the student, basically. So this duplicates almost full the function of the vehicle.
Right.
So that's an expensive thing. You add 10 of these on, you now get a much more in-depth learning with larger number of students here.
Right.
All right. Okay. Right. Very good. So I think that gives you something to think about. It gives you the overview of our electric vehicles. We have a complete program. This is not all the EV systems that we do, but it's a lot of them.
Yes.
You know, we have definitely the world's largest
Toyota,
range.
the fuel cell before also.
Fuel cell systems, right? Yeah. We have so many, and of course we have full hybrid programs too as well. We have now developed to being global leaders in the depth of the technology that we're able to teach and how we're able to teach it. And we can reach more students at a lower cost through these systems, which has really been an aim of Labtech, to be able to do this for all of our clients and universities and customers around the world, to enable more learning to be done at a wider scale at lower cost. Okay, so now we hope that we can go over and do a brief introduction to Labtech for 5 or 10 minutes. And Brad, you or Arno are going to do this, I believe.
Arno's speaking. I'm running his slide for him, Steve.
Okay,
Can you hear
sounds
me?
good. Good
Teamwork.
cooperation.
Yes.
Can you hear me, guys?
Yes,
Very clear.
loud and clear.
Okay, good. So yes, really sorry about this glitch on the computer here, but Zoom is just not playing with me today on the laptop. So we had to have a plan B, unfortunately. So right. Yeah, next slide if you want, Brad, please.
We might disconnect.
So yes, as you probably already know, most of you, so the company is actually celebrating its 40 years, actually end of last year, if I recall correctly, Steve, or correct me if I'm wrong, but it's 40 years already.
Arno, can you unmute, please?
Yes, sorry, can you hear me now?
Yes, loud and clear. Sorry.
Okay, okay. So I was muted for how long?
Yeah, only
A few
about
seconds, I guess.
10 seconds.
Okay, okay, okay. So the company is very well recognized worldwide as one of the technical teaching solution provider
Telephone
worldwide.
fine.
And we have our factories ISO, all our process are ISO 9001 accredited. So we have multiple offices. As you can tell, we have okay, next slide, please, please, Brad. I will go through the regional offices in few seconds. So the core of the company of the teaching solution has been really focused on really three large pillars, which is the leadership programs that have been in place for many years already, but is actually the ideal development for the ministries and institutions in order to upgrade their curriculum, update and upgrade their curriculum, and take everybody on board for the progress of the employability skills in the country. Also, the Labtech Academy digital platform, which has been around for also nearly a decade already with us. Specialized on three large contents, the digital content on refrigeration, air conditioning, automotive, electrical. We also have a lot more disciplines right now that will be also implemented in the coming months. We will come back to this in very shortly. And of course, the hands-on training systems, over 1,000 different types of training systems, with the digital twin integration that we have seen also literally just only a few minutes ago with the demonstration that has been made. Brad, can you do the next slide, please? Thank you. So these are the Labtech's ecosystem teaching solutions. So going through from the top right to bottom. So we have refrigeration and air conditioning training systems, automotive training systems, as you've seen here also a few seconds ago, electrical training systems, electronics, renewable energy, ICT or telecommunications and networks, biomedical training systems, the digital learning systems as the academy and other XR, VR, and AR teaching solutions, and also the leadership programs that are part of these full ecosystems here designed for any institutions around the globe covering these disciplines. Next slide, please, Brad. So this is what I was mentioning just a second ago about the new training solutions that are coming now into place. So because we are obviously very much in contact with all the ministries and institutions around the world, so we can detect the new trends or the new requirement for the market. So in order to match the skills that are required in every country, and these are the top ones that will be soon implemented within our catalog. So the motorcycle mechanics, STEM foundations, agricultural and smart agriculture, new training platform for the IoT, heavy duty vehicles for mining, construction, and agriculture. We have already a few ones that are already been implemented, and also new thermodynamics training systems on a heat transfer, heat exchanger, etc. So this is also coming in the coming months. I would say 6 months to a year. We will have a large new suite of training solutions for you. Okay. Next slide, please, Brad. So can you click on the arrow button or the space button somewhere? You will see, there you go. So this is where the factory is located. And then we have also multiple offices, 7 offices around the globe. So Australia, Jakarta, Singapore, India, Jordan, and more recently, we have Mr. Paddy here in the team from Kenya and also from the US. So this is literally covering the whole globe for you, and this is the whole presence of Labtech International. So should you have any requirement, any questions from any of those areas, somebody will be there for you, literally in your time zone, almost. So next slide, please, Brad. So this is the coverage that we currently have. This is the present that we have. So everything in blue that you can see on the map here are where the teachings, different types of teaching solutions have been supplied in recent years. So literally, I don't know. It's over 100 countries already. I don't know how many are missing still on the map here, but it's only very, very few. Even my home country there, it seems to be missing. So we'll need to look into that more closely, definitely. Next slide, please, Brad. So how we operate, how we work here at Labtech is we actually do absolutely everything in-house. As you could tell from the training system that you've just seen a few minutes ago, so there's nothing there available on the market. Everything has to be designed in-house. We do not subcontract. Everything is actually designed in-house. So we have approximately a 30 people team of R&D engineers in-house. We also obviously do the manufacturing, which is the largest part of the company. We have a packing department, our shipping department. So the majority of the time we actually dispatch to the location of the end user. Obviously talking about the physical hands-on training system. So we take care of the whole logistics from factory to almost door to door whenever requested or possible. And we also have a team of installation engineers. So again, whenever requested, we can also support you with the installation training of our digital training systems or hands-on training systems on site for you. So again, the whole team is there to support you anytime, anywhere. Okay. Next slide, please. So we've been participating, just to let you know, we've been participating in many events over the last few months, and this is one of them. One of the extremely important one was in the Philippines, in Manila, only a few weeks or a few months ago, back in December. The Asian Development Bank Skills Forum, where we attended this event with the whole team there, and we had the privilege to speak to highly stakeholder ministers, all related to the TVET institutions, all from the region, literally from Turkey to Australia, even from the some of the tiny islands in the Pacific Ocean. So literally, this is the global events that is gathering all the TVET skills, all the TVET stakeholders from the region. Extremely important, and Labtech was part of this important events, as you can tell here on these slides. Next one, please, Brad. So, as I was mentioning also a few minutes ago, so this is the whole team at Labtech right now. Not on the picture because we didn't fit, but here listed on that slide. So Dr. Steve Mackey, president and founder of the company, is obviously extremely important. Also leading the group here for all marketing activities across the board. Mr. Shafiq Sultan for Asia, Mr. Indra for Indonesia, our SMS manager here based in the headquarters here in Batam, Mr. Brad Kerr, director of the digital departments and in charge of the Southeast Asian market here for Labtech, Mr. Deepak, in charge of the India, Nepal, and Bhutan, myself for the Americas and Europe, Mr. Mike Cochrane for Australia and Oceania, all that part of the world. Mr. Shir Sultan, Southeast Asia, Malaysia. Mr. Paddy Nguyen, who has been newly integrating the company only a few weeks ago, taking care of the African region. He's located in Nairobi in Kenya, and Mr. Izu, who is in charge of the Middle East. Many of you may already know Mr. Izu. I'm not sure about for the Americans, obviously, but Mr. Izu rejoined the company only a few weeks ago, and he's very well known here at the factory and with our esteemed clients. From the factory management, we have Dr. Steve, Mr. Echo, I believe is nearby at the factory also at the moment. So Mr. Newman, who was on the video right now with Mr. Steve, Indra, and Mr. Sherry also from the V-Learning team. I believe, Brad, that we can, I think we can leave it up to now. The next ones are not necessarily, you will be
Yeah, I cover some
clearing.
of those. Yeah.
Exactly. So I think you're going to go through some of those anyway for the leadership programs and the blending learning. So yeah, thank you.
Fabulous. Thank you very much, Arno. That's great. So am I continuing on straight away, Steve, or am I going back to you?
Yes, I think you could continue on because they are, can you hear me, Brad?
Yes, can hear you. Yeah.
Okay. Because I'm through my alternate mic. They can, you could continue because we're just charging the camera for a second. So it
Okay.
seems like, yeah. So go ahead and then we'll continue on with the tour a little bit.
Okay, excellent. I'll just share my screen. If someone can pin me, please, that would be great. Then I'll share. Fabulous.
We can see a screen grab.
Okay, you can see my screen and also,
Yes.
great, thank you very much. So Labtech, we're about empowering future-ready graduates with immersive digital learning, scalable training solutions, and comprehensive capacity building. So Labtech Academy now is one of the leading global digital transformation of TVET organisations in the world. And I'll say that we've been positioning Labtech Academy, right, in various subject areas. And it's very important that we represent not only digital, but capacity building, right, is very important to us. Our role is very clear. We focus on virtual TVET, interactive 3D digital content, and national scale capacity building. Around the world, skills education is under pressure to scale faster, reach further, and remain relevant to industry. Labtech Academy exists to address exactly that challenge. We are redefining how skills are taught, learned, and scaled, not by replacing hands-on training, but by digitally enabling it. We deliver a complete virtual TVET ecosystem, combining immersive digital content, smart learning platforms, and structured capacity building programs. Our focus is on one outcome, and that is future-ready, employable graduates supported by confident teachers and digitally capable institutions. When I say this, I want to be very clear. From individual classrooms all the way to nationwide systems, Labtech Academy is leading the next era of skills, and that's very important to us. Labtech Academy is leading the way in the era of skills development also. TVET must evolve fast, no longer putting off. Let's talk honestly about the challenge many of us are facing around the world. Traditional TVET systems are under growing strain. Complete physical labs are expensive to build and maintain, and in many cases they involve real safety risks. especially as we move into EVs, high voltage systems, automation, and advanced technologies. And don't get me wrong, you still need the physical systems, are very important, but digital is a great learning curve. Digital is very important that we adapt and adopt it at an early stage to actually reduce a lot of those risks, especially when it comes to EV. And access is another major issue. Rural, remote, and underserved regions often struggle to receive the same quality of training as urban centres. At the same time, technology is evolving faster than curricula can be updated, and teachers are being asked to deliver modern skills without always having the digital tools or pedagogical support they need. So the question becomes, how do we modernise TVET without compromising competency or industry relevance? Labtech Academy's response is a safe, scalable, and cost-effective virtual TVET model. One that strengthens learning outcomes while supporting physical training systems, not competing with them. Remember that. We are supporting the physical training systems, not competing with them. I've just got a very quick video here just showing you some of the simulations that we're doing. And this is just a minute taste of some of the hundreds of topics we have. And I'm going to jump through a few, just due to time, but as I said, all this is being recorded. Everything is interactive. You can control it, you can rotate it, you can change the factors, and it's the beauty here at Labtech is because we deal in the physical training systems, we can use real data in our simulations, and that's the difference. A simulation uses real data, not like an animation. So everything we do uses real data. I'm just going to jump through a few here. Again, here we have a residential central air conditioner central unit. Up on the top left, you have the control, like a remote. You can change the speed, the fan speed that is. You can change the temperature. You can change it from cooling to heating. It all adjusts because we use gaming technology, so it reflects in the simulation. I'm just moving through and jumping through here, so it's not yours, some electrical. We've had people in the electrical business for 30 plus years and go through some of our electrical content and said they've deepened their understanding and learned more in 3 hours than they have in 30 years. Again, fully interactive, and you can adjust it. Again, residential wiring. Make it look realistic. If they connect it up right, correctly, you can turn the switch on. So now, turn it on, turn the switch on, and the light comes on. Renewable energy. Again, many instructors, teachers, professors, doctors around the world say this is very hard to show, speed angle calculations on the blade speed and wind velocity. We can actually change this and again, make it very interactive. jump through a few more. Again, automotive, electronic ignition system. Again, fully interactive. You can rotate it using your mouse or touch screen. Again, hybrid vehicle, electric motor. I just wanted to show some of those. So, Labtech Virtual TVET ecosystem. It's one integrated digital architecture. This is very important because virtual TVET is often misunderstood. Virtual TVET is not a single product, and it's certainly not just online learning. It is an ecosystem. At the core is our TVET learning management system and LXP learning experience platform, which are skill-based, competency-driven, and designed to operate both online and offline. Layered onto that is interactive 3D digital content built using gaming technology, simulations, even the digital twin concepts that you've seen today. So learners are not just watching, they are interacting. We then integrate XR technology, being augmented reality, AR, and virtual reality, VR, and mixed reality, MR, to allow learners to practice complex or high-risk procedures in a safe, risk-free environment. Everything is supported by IoT-enabled analytics, meaning learning outcomes are measurable, trackable, and continuously improvable. And finally, all of this can be deployed through mobile and smart classroom infrastructure, making it scalable from one institution to an entire country. The results, I should say the result is a future-proof digital learning ecosystem aligned with international TVET standards and designed for real-world implementation. So our digital content portfolio covering priority industries, and it's expanding fast. Let's look at what learners can actually train on today. Labtech Academy already delivers interactive 3D digital content across key priority sectors: automotive, including light and heavy vehicles, electric and hybrid vehicles. Then we have air conditioning and refrigeration, HVAC. We have electrical engineering. We have renewable energy and biomedical technology. These are not generic simulations. They are industry-aligned, system-based, and competency-focused. At the same time, we are expanding rapidly. We are actively developing new content for motorcycle technology, welding and fabrication, smart agriculture, and digital aquaculture and fisheries systems. The key advantage here is modularity. All of our content is interactive, modular, and continuously expandable. This ensures long-term relevance and protects institutional investment as technologies evolve. So learning without limits, anywhere, anytime, and it's online or even offline. One of the most practical strengths of Labtech Academy is flexibility. Through our LMS, and that's our TVET LMS and LXP, and the mobile learning case, institutions can deliver training with or without internet connectivity. That is absolutely critical in many regions. You can operate from fixed labs, mobile units, satellite campuses, or temporary learning sites. Training can continue during disruptions, whether that is connectivity issues, disasters, or logistical constraints. Importantly, institutions can start small and then scale confidently to regional or national rollouts. The outcome is equitable access to high-quality skills training, regardless of geography or infrastructure limitations. Another important thing is our capacity building that drives system change. From leadership to the classroom, technology alone does not transform TVET. People do, yourselves. This is why Labtech Academy places such a strong emphasis on capacity building, and why these programs are now gaining traction at a national level. At the leadership level, we support the development of digital TVET frameworks, institutional and national transformation roadmaps, and policy-aligned implementation strategies, like we are currently doing in Sri Lanka and Philippines and Malaysia and many other countries showing interest. At the teacher level, we focus on practical capability, how to deliver virtual TVET effectively, how to integrate interactive 3D and XR into teaching, how to apply heutagogical approaches, and how to use the TVET Learning Management System analytics to improve learning outcomes. When this is done properly, institutions don't just adopt technology, they move from adoption to ownership to innovation. So heutagogy and employability, designing learning for the future workforce. A key educational principle behind Labtech Academy approach is heutagogy, learning that is self-directed, experiential, and relevant to real work environments. Virtual TVET allows learners to engage in problem-based, industry-aligned tasks, to practice repeatedly in safe digital environments, and to build confidence before entering the physical labs or workplaces. This results in higher engagement, better retention, and stronger competency development. The outcome we see consistently is graduates who are job ready, adaptable to new technologies, and confident operating in real world environments. And this is my last slide. The future with Labtech Academy. The journey has only begun. To conclude, the future of TVET is very clear. It will be digital first, data-driven, immersive, and scalable at national level. Labtech Academy continues to invest heavily in new industry content, advanced 3D, XR, and digital twin technologies, stronger analytics, and AI-enabled learning pathways. At the same time, we are expanding our capacity building partnerships across regions and countries. And I want to leave you with one final thought. Labtech Academy is not following the future of TVET, we are building it together with our partners. Thank you very much.
Good, Brad. Very nice. A great class message too, as well, that we're building the future. We're just starting the camera down.
Yeah, if we can remove the spotlight and back to Dr. Steve at the factory, please. Just to tie up, we're just finishing up. Thank you.
So we're just starting the camera up. But Brad, maybe we should also we could share with the people that during the registration we had a lot of interesting questions asked of us, and that was going to be able to share with all of our participants, both that registered with us on YouTube and Zoom, the answers to those questions, and you already have drafts of that. And if you or Arnold could show that for a second, and share with the audience that this will come back to you. Also, please also, there'll be a survey that everyone is expecting to fill out additional questions you have or ask them on the Zoom chat also as well. And we'll take note of these and you have a sample of the draft that you are on the chair?
I don't have the one that because of Arno had on his computer, and I don't think he's shared, unless me just check the messages, whether he's got. No, it doesn't look like. But what I would like to share is that I have a link to share for everyone giving some feedback. I will put that in the chat. Got that from Arno now. All right, so we've got a Google form here. We appreciate everyone, and we apologise we've gone a little bit over time. I'll just make sure this is going to everyone. We've got a form I've just put in the Zoom chat. We appreciate everyone completing that, and then based on completing, it's a very short, only takes you a couple of minutes to complete. And after completion, we will actually be sending you out some more information on Labtech and all our catalogues. So appreciate everyone there. Thank you. It's in the Zoom chat now. And the answer to the questions we'll probably send you, because I know Arno's had a few technical issues with his computer, so he couldn't get access to that document. So apologies there, but we will get that to you too. There were lots of fantastic questions asked, so we will make sure that you get a response to those questions. Thank you. We seem to be pinpointed on you, Dr. Steve, at the moment.
Oh, I see. Okay, right. They're still trying to back on connected wall during the presentation from here to Arno.
I'm back again. There I am.
Okay.
Back on screen.
But I could actually start. I could actually video on my phone, and we could start with that. With just a second.
Okay. Okay, we're just wrapping up now, and Dr. Steve will have the a final few words with you all. Again, we do appreciate you staying a little bit over time. And as said, if in the form there that you can put any further information, and even in the chat, if you have any questions, we will get back to you also.
Brad, look at the chat.
I can see the VLearn iPhone pointing somewhere.
Okay, all right. You're connected. Are the bags connected?
Yes,
Can
it
you
is.
hear
I
me?
see your hand.
Can you hear me?
Yes, hear you loud and clear.
Okay, we're good. We're live. Yeah, fun with technology. Okay, so we're going to really, because we are running a little bit over time, we're going to try to finish up in 10 minutes. We'll just take you a quick walk through other parts of the factory and see what we'll discover along the way. So this is a training system that I think had several versions of previously. It's our most complex that has various types of heat exchangers, both water and air, multiple heat exchangers that are able to be configured in many, many different ways. This is part of air conditioning refrigeration, thermodynamics too as well. It's a fantastic dual purpose training system. One of the more complex ones around. This is technical institute university level. Particularly when you add on the digital twin side of this. And this is much like our other digital twins, except one special thing that's on all of our air conditioning refrigeration is the pH or diagram of psychometric chart. This is fully interactive with its data.
So as you may change the control on the training system, this will interactively change dynamically.
Following the data from.
Can you change something that?
Yes, right. Before that, I showed a quick drawing for the diagram. It has for heat exchanger. So it has the quite complex system actually. Can be selected from air to air, or air to water, water to air, and water to water. Water to water, when the heat exchanger using two types of water type heat exchanger. This is the chart like this. If we change add water of this one. And add to add. It's off now. It's on add and go on again. It is on add to add. Slightly different parameter. Add.
I'm going to switch over to my other mic for a second, because they're playing with the sound on this. It's not transferring there. Well, using my other, my channel. You still continue to try. So. We're gonna have to follow on. Look at the background here. Hey.
So here you see back in here, we're assembling various types of air conditioning training systems. These are actually some of the skills kits, which the students will be also doing. But the first pre-build is sent out. So here was an example, but then all the materials come to take it apart and build it.
We also have some of training here. This is one of our here.
These are sight glasses of a special type that are on that are in graduation for this. The first one is gas, so you see that's empty. And then the second one, you see some slight movement through it, and that's because it's mixture of gas and fluid. And then the bottom one, there's fluid. You turned it off? It's turned off.
Oh, yeah. With the temperature. Okay.
Yeah, but I can't show this now.
All right.
We'll come back.
Hi, Steve. We're getting a lot of feedback too.
Yeah, here. Okay, so I will turn that off. Now, is the sound okay? Is it clear again?
See that the liquid is flowing at the bottom side. When it's full liquid, there's something we might not be able to see when the glass is full.
Okay. All right. Hydronic systems, which are heating systems for houses that are done by water. This is heat generator. You can take the most efficient one. This is actually fully operating. So we have gas or kerosene or oil fires depending upon where you live in the world. My grandfather used to have one powered by solder. Great power. And then you have your different types of radiators. Yeah, either kind of long or thin floor. And you're pumping to them to change. I'm thinking for something that I do it. As your age.
Hot and cold water will be not the December family.
Okay. I think the voice is breaking up again. Voice is breaking up again. I'm just switch back to my other microphone. So we're going to turn on this. Go back to my other microphone. Okay. So,
walking by, one of our partners that this is for about event for these technologies.
We do a lot of things in different types of new refrigerants, from R600 to R290, commercial CO2 systems, all the different types of new refrigerants that are promoted and encouraged by the UN Montreal Protocol, Valley Protocol also as well. So this is something that should be built into modern air conditioning HVAC curriculum. Often not. It's certainly encouraged by the UN, and we set up special labs to do this. But really, traditional HVAC labs type of a segment in any good HVAC area, because this is the new technology that we need to learn. And we have a lot of different things. Learning more about the
We have a lot of factories, areas going on back.
we have heat exchange systems. This is part of our thermodynamics line. Here we're going to walk past various simulators. This is two-wheeler simulator. Also, a very nice digital twin on this one. I wish we had time to demonstrate that. Electric vehicle simulators with digital twins. So this is like mid-level for electric hybrid vehicle, also electronics. Can be taught in this way at a very comprehensive way before you move to the actual vehicle itself in the training system. This is a Canvas training system too, as well as simulation. Here we see combined solar and wind with a very nice digital twin. So in this system, we're able to have the solar panel and the wind to have energy fed into the system, selected and controlled by the system as well, so that it would represent like a multi-energy house with multiple energy sources. And it has all your control systems, your inverters, and again, you have your Wi-Fi connection here, and your displays, you have loads. You can see the various currents going through here. This is the wind unit, small wind turbine, about 300 watts. A little bit similar for the solar panel with the light source also, that has less power than the wind unit, but combined.
Danger module here for thermodynamics area. This is a heat exchange trainer here.
Set up with one of those modules.
Changeable.
This is really a marvelous system that really you can explore a lot of different heat transfer areas and things like this. And they're also very good digital twin with plotting and things like this. This is the new unit which simulates hybrid vehicles, fuel cell vehicles, and electric vehicles all in one simulation. It's if you had to choose one trainer and put in your school and you want to do everything, this is it. You can even change the application, so you have this is a series hybrid vehicle block diagram. This is a parallel hybrid vehicle block diagram. So you use series, parallel, electric vehicle, fuel cell vehicle.
Yeah.
So just by changing this and the functions, you can then
And all the system will be changing.
all the systems will be changing.
All the program for the electromotor, for the display, and also the profile will be changed. It has this special ID here.
Right.
When we connect this ID, it goes to the fuel cell.
Perfect. And then everything changes here. The digital twin can adapt to whatever you're studying on this one then too, as well. Right. So what else you're seeing out here is back behind me. I was going to take you on a tour, but I think we're running out of time. I'm sorry, just checking on a message here. So are you saying I should change my mind to this one? Is this mic working? This mic is working. Okay, right. So behind me, what we have, coming this way, is our R&D area. And all these engineers here, R&D does not sit off to the side in the Labtech structure of the factory. They actually sit across all the production departments. Our R&D is the production. Okay, I'm switching over to my other microphone. I'm sorry, this is a little annoying for everybody, but try to keep up and get on here. So the R&D actually runs the factory, and this is why Labtech continuously designs and innovates. It's part of our routine structure and processes. So every time we make a new training product, if it's an existing one, we upgrade it. And if it is a new system, it also goes through the same procedures that it goes before it goes into production. So they monitor the designs, issue the production work orders, and do the testing for this. And then behind me here is our digital learning development department. So here we have about 40 programmers and developers for the digital content that are all working on creating that wonderful interactive things that we were looking at. And they are all a bunch of very talented young people back here, and they do a fantastic job. So we've been having a lot of fun with the integration of this digital learning into the physical. And we've been dreaming and planning about this for many years, and we're able to push the boundaries here of what we can do and develop the talents at Labtech very systematically so that it occurs in a effective way for teaching and learning. And that's where Arno and Brad were saying is we're a company that's headed by educators. So we are really good engineers in many multiple levels, but everything we do is applied towards education. I think that's the end purpose, and that's what we're working for as a goal. So it's not just a couple of cool products, but we're creating the educational platforms for the future of both a digital and a physical world. In fact, our new trainers, the digital twin, another word for it is cyber physical training systems. And this will enable us to do much more for our clients around the world. So with that, I think we come to the end of the factory tour. We've just gone a couple minutes over time. And Brad, Arno, any final comments from you before we say goodbye to all of our friends and colleagues from around the world?
Other than thanks for joining, please contact us for any further information you may require. And remember, innovation for TVET is the future. Thank you very much.
Okay, thank you. We'll sign off from now, and thank you for joining us this morning. And we will probably host this a couple times a year on different subjects. I think in the future, Brad, we can focus on the capacity building, or we might take a deeper dive even into the virtual learning or the digital twin. And also later on this year, we will do highlight different subject, different training areas as they come through the factory. Because every time you come to Labtech, there's a different flavor. This month it is EV and air conditioning more than anything else. Next month it could be electrical and renewable energy. So we change through the production cycles depending upon customers' requests and demands. And so it's always interesting to do a factory tour. You always see new things, and we're always developing new things. That's why you always see new things. Okay, thank you very much. And we'll be signing off from Batam. Have a great day, and we look forward to any questions on the feedback form. I apologize for the technical interruptions today. This will get smoother as we go along. Thank you so much. All right, bye.